Okay, this video is going to talk about the number of roots that you have and whether the roots are real or are they complex. Before we get into that, let's do a little baby review on complex numbers. I is the square root of -1, which means I squared itself is -1. I'm not going to do much with I cubed, but I raised to the power of 4 is +1. The most important things that we need to focus on basically, though, are right here. This is probably the most important thing that we will encounter this year. A complex number. So a complex number, two parts, A plus BI, A being the real part, and BI is the imaginary part. And let's do a little review with imaginary numbers, simplifying imaginary numbers. So here, radical -25. This is -1 times 25, and you would simplify that as 5i. -50, -1, 25, and 2. So this would simplify as 5i, radical 2. And -8, -8, -1, 4, and 2. This is going to be 2i, radical 2, just to do a little review on simplifying complex numbers in radical form. Here, we can actually talk about this whenever we have class again, but just to do a few little things here, real number roots are x-intercepts, meaning they cross the x-axis. Complex numbers do not cross the x-axis. Complex do not cross the x-axis. X-intercepts do cross the x-axis. Real number roots, rational or irrational. And remember, the irrational occur in pairs. These occur in the positive-negative pairs. That's from the last quiz. Complex roots also occur in pairs. So they occur in positive-negative pairs. So that's something they have in common. And of course, we find all of these by factoring. And we can find these by factoring. That's how we find them. Factoring, and throughout just that's how we would find the roots. We use synthetic division. It's all a big process that we'll get into, and I can refine that a little bit more. But what I really want to talk about is this. The number of real roots and the number of imaginary roots always equal n, the degree of the polynomial. So always equal n, the degree of the polynomial. Here, I'm going to skip through this, and I want to go down here. I'm going to skip that. I want to go right here. Number of real roots plus number of imaginary roots, right here. Number of real roots plus number of imaginary roots always equal n, the degree of the equation. And one of the skills in 2B, in standard 2B, is to list how many real, how many potential imaginary numbers you have. So here, I'm given a degree 5 polynomial. And when I add up the two combinations, I always need to get 5. I would want 5 here. So draw columns. Imaginaries are occurring in pairs. So that means I could have 5 real roots, no imaginary roots, giving me a total of 5 roots. I could have 3 real, 2 imaginary, giving me a total of 5. And that's really all. Those are my only no, I could have 1 real and 4 imaginary, giving me 5. Imaginaries occurring in pairs. Let's go down, let's do this one. So here, you're given a degree 8. And let's make our columns. I could have 8 real, no imaginary, giving me a total of 8. 6 real, 2 imaginary, giving me a total of 8. I could have 4 of each. I could have 2 real, 6 imaginary, or I could have no real roots. They could all be imaginary. Notice the imaginaries are always occurring in even number pairs. All right, let's go down here and let's look at number, let's see, we did 8 and we did 5. Let's do 4 and let's do 6. So here we go. You're asked to list the number of real, number of imaginary, and I'm always wanting it to equal 3. I could have 3 real, no imaginary, or I could have 1 real and 2 imaginary. Those are my only 2 scenarios for that. Adding my rows up, I always get 3. Looking at the next one, real versus imaginary. Let's see, I'm wanting to total 6 every time. I could have 6 real, no imaginary. I could have 4 real, 2 imaginary. I could have 2 real, 4, or no real, and they could all be imaginary. The important thing is that the imaginaries are occurring in even number pairs. And for this video, I really think that's all that I want to do. I'm not going to worry about the number of positive and negative zeros per function. I'm not going to worry about that too much. And we can do a few things here, and then we'll clean this up when we have class again. We can list the number of complex zeros, real and imaginary, and the possible rational zeros. I am going to cross this out, stating the number of positive and negative. I'm going to skip that. Let's do 2 of these together on the video, and then I'll stop this just to practice everything that I've tried to explain. So looking at number 3, let's do our real imaginary thing here. So let me get my pen back. How many real roots? How many imaginary roots? And then we'll do the P over Q. And I'll do 2 of these, and then I'll stop. So let's see, I've got a degree 3, so I could have 3 real, no imaginary. I could have 1 real and 2 imaginary, and that's all. P over Q. So remember, the numerator, factors of the constant, the denominator, factors of the lead coefficient. So this is my candidate pool. If I were to factor this and break it down all the way, these are numbers I could use to get started with synthetic division. So my numerator would be 1 or 3, and notice I've got the positive, negative, so the positive and negative case, and my denominator is just going to be 1. So actually that's a pretty small pool of numbers, and that would be pretty easy to sift through that. Let's do number 4. So here we go, number 4. I want the real, I want the imaginary, and then I'm going to list my potential rational roots. Positive, negative, and here we go. So real, imaginary, this is a degree 5. So I could have 5 real, no imaginary, 3 real, 2 imaginary, 1 real, 4 imaginary. That's my possible root, or that's the type of numbers I can have. P's and Q's, so here we go. 12, hold on, not the highlighter, 12. All right, so 12, that's my numerator, and my denominator. And here we go. All right, pen come back. And here we are. So my numerator, factors of 12, 1, 2, 3, 4, 6, and 12. And my denominator, 1 and 2. So if I were to get started on the synthetic division process, I could pull a number from the ratio P over Q. They would be my potential divisor candidates. So I'll call it for right now, kind of my divisor candidates. And then we'll wrap this up more when we have class again.